So today you're going to be learning about a new kind of function called an exponential growth or decay model. You guys have learned about these before in Algebra 1, and a lot of the characteristics it has is the same as the ones that we worked on in last chapter of how we shift left or right. So if you look at an exponential function, it's going to be in the form y equals a times b to the x minus h power plus k. The parent function, which we've talked a lot about before, the parent function of an exponential graph is y equals a times b to the x. The parent graph is always going to pass through 0a. Whatever a is what it will pass through. That's also going to be called the y-intercept. So this point here, that's our y-intercept. 0a is always going to be the y-intercept. It's where the parent graph will pass through the y-axis. Then, to find another point on that graph, just substitute 1 in for x and simplify to get what y is. Another important feature of an exponential model is called an asymptote. And an asymptote is an imaginary line that the graph will approach, but it will never cross. We'll be looking more at asymptotes coming up. The domain is always going to be all real numbers. So if you were asked to find the domain of an exponential function, it's always going to be from negative infinity to infinity. The range then is determined by what a is. If y is greater than 0, y will be greater than 0 when a is greater than 0. Y will be less than 0 if a is less than 0. Then again, h and k determine your shifting. So the opposite of h shifts you left and right. K always shifts you up or down. So a little bit on asymptotes. I already said that it's a line that a graph approaches but never crosses. If I look at this first graph here, the asymptote is the x-axis. It's this line. Notice that the graph of y equals 2x approaches it, but it is never going to cross it. It gets really, really close, but it doesn't cross. In the next one, the asymptote is at y equals -3. It's down here. The asymptote is always going to be at x equals k. So wherever k is, that's where the asymptote is. And sorry, that should be y equals k. It should be y equals k, not x equals k. You should go back and fix that on the first page too. Sorry for the typo. So when we're graphing exponential functions, it's important to always identify where that y-intercept is going to be and to also identify where the asymptote is. So the asymptote, remember, is always going to be at y equals then whatever k is. So the asymptote here is at y equals k, -3. So the asymptote is at y equals -3. Then to get the y-intercept you get by putting 0 in for x. So I do y equals 1/2 times 2 to the 0 minus 3. So in order to get the y-intercept, we always plug in 0 for x. Then you simplify that, and you get that y is -2.5. So the y-intercept is at 0, -2.5. That's something that's very important for you to find because it's going to have special characteristics as we go throughout the rest of this chapter. Let's do the same thing for this next example. Let's find what the asymptote and the y-intercept are. So the asymptote is going to be at y equals 1 here. So this is our asymptote. That's that line that it's going to approach but never cross. Then the y-intercept is at y equals 3 to the 0 minus 1 plus 1. So anytime we're looking for the y-intercept, we plug in 0 for x because at the y-intercept, x is always 0. So this simplifies to 1.33. So our y-intercept is at 0, 1.33. And that would be a point where you could just approximate at approximately 1.33, so somewhere in between 1 and 2. Pause your video now and try that final example. Determine what the asymptote is and where the y-intercept is located. So you should have gotten that the asymptote is at y equals negative 2 and the y-intercept is at 0, negative 3. In the next day of examples, we're going to be learning a lot about exponential growth and decay, and then you'll see where exponential growth and decay are used in your everyday life. It's something that you're going to be seeing as you grow up a lot. So, exponential growth and decay functions, they're determined by what a and b are. So, if it's an exponential growth equation, it's going to be an equation that looks like this. It's going to be growing from left to right. An exponential decay equation is going to be decreasing from left to right. So an exponential growth has a greater than 0 and b greater than 1. An exponential decay also has a greater than 0, but b is between 0 and 1, so it's either a fraction or it's a decimal. So what you always want to do is look at b, and that determines whether you're going to have a growth or decay. In example A, b is 3. So since 3 is greater than 1, you are going to have an exponential growth equation. In B, part B, b is 1/3. That means you're going to have an exponential decay equation. And then in part C, b is 0.99. So again, you'll have an exponential decay equation. So now with graphing the functions, in this one we're going to graph y equals 3 times 2 to the x minus 1 minus 4. So what you always want to do is lightly sketch the graph of the parent function. So the parent function here is y equals 3 times 2 to the x. So I always lightly sketch that, and then I'm going to shift it. So how you lightly sketch it, you determine 2 points that it passes through. So what you want to do is plug in 0 for x and 1 for x, and you'll get your 2 points. So when I plug in 0 for x, so that's determining my y-intercept, I have y equals 3 times 2 to the 0. Well, any number to the 0 power is 1, so this is 3. So 1 point that it passes through is 0, 3. Then to determine another point it passes through, I substitute 1 in for x. So I have y equals 3 times 2 to the first, and you get 6. So first, I plot those 2 points, 0, 3, and 1, 6. And I just sketch that and lightly sketch it because you're going to shift it. That's just your first initial parent graph. Then next, you're going to draw a dotted line at the graph's asymptote. So the graph's asymptote here is at y equals negative 4. So I draw a line. I'm going to put a dotted line through y equals negative 4. That's going to show me the line that it approaches, but it does not cross. Now I want to translate that graph. So it's going to move to the left 1. Oops, sorry. It moves to the right 1. Let me fix that. It moves to the right 1 because it's the opposite of what's in the exponent, and then it moves down 4. So I'm going to take those 2 points that I found, move them to the right 1 and down 4. So to the right 1, down 1, 2, 3, 4. And then the other one to the right 1, down 1, 2, 3, 4. And then I want to draw my exponential growth curve so that it approaches the asymptote but does not intersect. So the black curve here would be your final graph. That's the graph of the function y equals 3 times 2 to the x minus 1 minus 4. So always go through the same steps for graphing. First, determine 2 points that it passes through. So substituting in x equals 0 and x equals 1. So when I substitute in x equals 0, I get y equals 3 to the 0, which is just 1. And then substitute in 1 for x. So you get y equals 3 to the first, which is 3. So my parent graph of this function passes through 0, 1, and 1, 3. So here's my parent graph that I'm going to shift. The asymptote here is at y equals 0 because there's nothing after. I don't have a k. So I'm not even going to shift up or down because there's no k. I'm only going to shift to the right 1. So I take those 2 points, I shift them just to the right 1. My asymptote is at y equals 0, so that's the x-axis, and I draw the exponential decay, exponential growth graph. Here we're going to have an exponential decay graph because b is 1/2. So you want to make sure that it's decaying, it's decreasing from left to the right, but the steps are still the same. So we first plug 0 in for x, so you get y equals 1/2 to the 0. That's still 1. Then plug in 1, you get 1/2 to the first power, which is 1/2, which is going to be a little bit harder to sketch, but just approximate where 1/2 is. So we're at 0, 1, and 1/2, so it's decaying this way. So that's the parent function. Then the asymptote is at y equals positive 3. So the asymptote that it's going to approach is up here. So here we're going to be shifting the whole graph up 3. We're shifting the parent graph up 3. And then we're going to shift to the right 2. So we're going to take those 2 initial points that we found and shift them to the right 2 and up 3. So I go to the right 2, up 3, to the right 2, up 3. And I have my exponential decay function there. Why don't you guys try that last example and see if you can understand this on your own. So try the last exponential decay graph. So check your answer with what is here. It's a little bit off on the graph because it shifted a little bit, but it should look pretty much like the black graph that's here.